Hello, greetings to you. My name is Mr. Tauseni. Welcome all of you to our maths revision class. Uh, this is a follow-up on the same work that we did last time. I did get a request from someone that I must explain again and give one or two more examples of the same thing. We are particularly focusing on differentiation using the differentiation rule. So the rule that we are using says that given y is equal to ax to the power of n, the derivative, which is dy dx, is equal to an x to the power of n minus 1. So basically, simply put, it means if you are given an expression which is y is equal to ax to the power of n, the derivative, which is dy dx, is found by multiplying the exponent times the coefficient. So a times n, that's an. Then we subtract 1 from the exponent to get n minus 1. That is how our derivative is found. So then we explained that before we differentiate, we need to make sure that we are clear. We can clearly see what is the value of a, what is the value of n, what is the exponent, and what is the coefficient before we differentiate. So to be able to check those two, there are three conditions that we gave that we have to consider just as guidelines. So the first condition is that there should be no square roots in your expression. If it happens that your expression has square roots, then we have to change the square roots using the laws of exponents, which says b root x to the power a is equal to x to the power a over b. Then we must also make sure there are no variables in the denominator. If there are variables, by this one, what we mean basically here is that, let's say I am differentiating y with respect to x, then x must not be in the denominator of my expression. If that happens, then we need to change that using the law of exponent, which says x to the power negative a is equal to 1 over x to the power of a. Then the third condition, there should be no brackets in the expression. If there are brackets, always remove brackets by multiplication and then you simplify. So these are the conditions. Let's have a look at one more example maybe and explain it. Right, determine the derivative if y is equal to 3x cubed minus 27x divided by x plus 3. Now we need to differentiate this. If it's like this, it's one term. Now in this one term, it is not possible to determine which coefficient and which one is the exponent, because we need a and n. Those are the two numbers we must multiply to get the derivative. So in that case, it means we must deal with the denominator here, which is x plus 3. If there are two terms in your denominator, please get this part. If there are two terms or even more in your denominator, it means you must use factorization to simplify your expression. So the top one is a common factor 3x. So we're going to factor out 3x from the top one. Then in brackets, we remain with 3x factor of x squared minus 9. And the denominator is x plus 3. Then we have factorized, but we have not factorized fully, because if you look at my numerator, we can see that x squared minus 9 is a difference of two squares that can further be factorized into two more brackets. So y is equal to 3x factor of x minus 3 factor of x plus 3 divided by x plus 3. Once our expression is fully factorized, then we divide common factors. So the x plus 3 at the bottom and the x plus 3 on top, we divide those two, remaining with 3x factor of x minus 3 only. Remember, we must have no brackets in our expression before we differentiate. So these brackets, we need to simplify them out. We now have got 3x squared minus 9x. Then from here, after simplifying the expression to this level, now we can differentiate. My notation changes from y to dy dx. A is 3, n is 2, an is 3 times 2, that gives me 6x. Then here, remember, if you differentiate x to the power 1 it becomes x to the power 0, which is equal to 1. That's how this x disappears. It's not actually disappearing, it's minus 9x to the power 0, which will give us 6x minus 9. This is the derivative for this expression. So important to remember, if your expression has two terms or more than one terms in the denominator, it means you need to factorize that expression, divide common factors, simplify whatever you are left with, and then differentiate. That is differentiation. Let's have a look at one more example to be happy with. Now maybe just one last example before I close this up. Let's have a look at more examples. Evaluate dx, that means differentiate this whole expression. Now look at this, and please take note, these questions are coming from your past examination papers, the final grade 12 past examination papers. Now I want to differentiate this whole expression. There are two problems that I have to deal with in my case. The first one is root x. I don't want square roots in my expression. The second one is brackets. I don't want brackets in my expression. So I'm going to handle those two. And that is done before you differentiate. Now look at this. The derivative of this expression, the exponent 2 means one bracket, the same bracket is multiplying itself 2 times. So that means I'm going to use the FOIL method to simplify this expression. Root x times root x, it gives me x. Root x times 1 over root x, this root x and that root x, they divide each other. That's how I get 1. 1 over root x times root x, I get 1 also. 1 over root x times 1 over root x, I get 1 over x. Then I simplify by adding like terms. The only like terms I have in this case is 1 plus 1. That gives me 2. Now I've got the dx of x plus 2 plus 1 over x. Remember, no variables in the denominator. So that means I need to deal with this x and change it into a negative exponent. So now I've got x plus 2 plus x to the power negative 1. Then I can carry on. The moment I'm done simplifying, I can see the coefficient for x here is 1, the exponent is 1. 1 times 1 gives me 1. Then the exponent for x will become 0. That means my x is gone. This is a constant. If a constant is differentiated, it becomes 0. Then here I have 1 times negative 1. That gives me negative 1. Then to the exponent minus 1, if you subtract 1, you get minus 1 minus 1. That gives you minus 2. Then my derivative is complete. X to the power negative 2 can be expressed as 1 over x to the power positive 2. This is our expression differentiated. So in order